Hi, I'm Rick Wagner, and I'm from the San Diego Supercomputing Centre, and I'm here at the SC11 conference in Seattle. And what you're looking at behind me are simulations of astrophysics that were done on Jaguar and Kraken at Oak Ridge National Laboratory. What's novel about these is they're very large scale. They're 3,200 cube numerical simulations, but in addition, one of them includes radiation feedback. So this is the light from early galaxies that have formed. These simulations were done as part of TerraGrid Awards and as in-seat awards by the Department of Energy. And they're intended to be the first large-scale simulation sufficient to compare critically with observation. The visualization that you're looking at here is something that is rather unique. It was in the difference between the two density fields between a fiducial run without the radiation feedback and with. If you just look at the blue pictures with the classic cosmology cosmic web, you can't clearly tell the difference unless you look closely at the small scale structure. So on a conversation over coffee with the colleague Robert Harkness, who actually ran the simulations, we decided to try taking the difference of the two, something you would do normally when you're validating code or maybe looking at the growth of a parameter. This gorgeous image is the result. It clearly shows the region where the light has ionized and heated the gas as it's flowed away from the early galaxies.
What is the size of the simulation?
Numerically, it's 3,200 grid cells on a side. Cosmologically, I'd have to double check. I believe these are small 80 megaparsec volumes.
And what is the time scale of the simulation?
In this case, this is still at the very early universe. This is at a redshift of 8. So, and if you think back, a redshift of 1 is about half the age of the universe being 13.7 billion years old. So at a redshift of 8, the universe is only about 1 billion years old. It's very, very young.
And what is the scope of this simulation? What do you want to understand at the end?
Almost exactly what we're showing in this video. If you look at this video and the other one showing the temperature difference, what we're looking at is when young stars form, the very first generation of stars, when the light from them starts to hit the gas around them, it begins to heat the gas, which raises pressure and lowers densities. And we want to know what the impact of that is on other star formation and on the matter distribution of the universe and on observations, because as it ionizes the gas, then it's no longer observable in methods like the Lyman alpha forest.
Okay, thank you very much, Rick.
Yeah, you're very welcome.